Welcome to your Business Calculus Lesson 4.1 on the chain rule. All right, one thing that you need to know is how to show that a function is differentiable. If a function is differentiable, it is also continuous. So if it's smooth, we know it's connected. The logic does not necessarily work the other way. If we know a function is continuous, we know the function might be differentiable, could have a cusp. We must also show that the function is smooth to know that the function is differentiable. Okay, so to make sure the function is differentiable at x equals a, we need to make sure the function is continuous at a, so that, in other words, the limit of f of a is the same from the left and the right. Okay, and to make sure it's smooth, we need to make sure the limit of the derivative as the function approaches a from the left and from the right is the same. All right, so we're going to find a and b so that this given function is differentiable. Note, sometimes problems like this will be phrased, find a and b so that f of x is both continuous and differentiable. That's great, but it's not necessary. We have to account for continuity in the process to account for differentiability. So if it just asks you to show that a function is differentiable, you've got to deal with the continuity component anyway. All right, so first we're going to make sure that the function is continuous. So we need to check that the limit as we approach -2 from the left of the function is the same as the limit of the function as we approach or as x approaches 2 from the right. Okay, so that means that when we plug in -2 everywhere we see x in the top rule, okay, so 2 times -2 cubed minus 6 times -2 plus 6 has to equal the second rule, a times -2 plus b, because the limit from the left and the right has to be the same. All right, so we simplify here and get -16 minus 24 plus 6, which is -34. And then we have -2a plus b. We have two variables. It's a good thing we need to work with another equation. So let's go make sure that f of x is smooth. All right. Second, in order to determine that f of x is smooth, we need to make sure that the limit as x approaches -2 from the left and the right for the derivative is the same. So first, out to the side, let's look at the derivative. The derivative of f of x, f prime of x, is going to equal 6x squared minus 12x for x less than -2. If you look, we just did the power rule on each of these terms. And then for ax plus b, if we take the derivative of that, the derivative of b is 0. The derivative of ax is a. So our second rule is that a is for x greater than or equal to -2. So that means that as we approach -2 from the left and the right, we have to have the same value. So let's plug in -2 everywhere we see x. So 6 times -2 squared minus 12 times -2 is equal to a. So 24 plus 24 is 48, and that equals a. We're going to go back and get that other value that we had. I remind you how we got it over here. We get -34, and we're going to do a -34 has to equal the a times -2 plus b. And so -34 has to equal 48 times -2 plus b, because we know the value for a. So -34 equals -96 plus b. And so we add 96 to both sides to get 62 equals b. So 48 and 62 ensures that our function is continuous and smooth. And so it is differentiable. Okay, so let's talk about composite functions just for a second. You've studied them before, but just to remind you, it's when you put one function into the other function. one function becomes the input of another function, or it can be the input for itself. A composite function is created when one function is substituted into another function. So given that f of x equals 3x plus 2 and g of x equals x plus 5, f of g of x means that we want to know what f of x looks like when g of x is the input. So that means we're going to do f of the rule for g of x. So f of x plus 5. So we look at the rule for f of x, and everywhere we initially had x, we're going to put x plus 5. So we have 3 times x plus 5 plus 2. So that gives us 3x plus 15 plus 2, which is 3x plus 17. Now we're going to do the other direction. We're going to do g of f of x. So that means we're going to take the function rule for f of x and plug that in everywhere we see x in the function g. So now instead of x plus 5, we have 3x plus 2 plus 5, and we end up with 3x plus 7. So the chain rule is for when we want to take the derivative of a composite. All right, suppose that g is differentiable at x and that f is differentiable at g of x. Then the composition f of g of x is differentiable at x, and its derivative there is f prime of g of x times g prime of x. So that is going to be something that's good for you to know. All right, we're going to use the chain rule to find the following derivative. We're going to find d dx of sine x to the fifth. All right, so we look, and the overall picture here is that we have the function of f of x equals sine of an input. So f of x is going to equal sine x. And then if we look what the input is x to the fifth, that is our function rule for g of x. So g of x is x to the fifth. You want to leave room to do f prime of x and g prime of x. All right, the derivative of f of x when it's sine x is cosine x. And the derivative of g of x is going to be 5x to the fourth using the power rule. Now, if you look here, we're going to multiply two things together, but we're going to multiply f prime of g of x times g prime of x. So we need to look at the f prime of x, but substitute in the value for g of x, the function rule for g of x, so that we have f prime of g of x. So f prime of g of x is going to be cosine of x to the fifth. Okay, so the rule for g of x is x to the fifth, so it is now the input. So now we do our multiplication. The derivative we want is going to be cosine of x to the fifth times 5x to the fourth. So we're multiplying f prime of g of x times g prime of x. And so we just simplify that to get 5x to the fourth times cosine of x to the fifth. You need to refresh your memory of the rules of derivatives you've already learned. Make sure you have the common derivatives memorized too. You'll want to know all of those. All right, we're going to use the chain rule to find the following derivative. We want d dx of 1 over 3x plus 5. So the overall function here is 1 over x, or function rule is 1 over x. So f of x is 1 over x. G of x is going to be what is in the denominator there. So g of x is 3x plus 5. Now we're going to come back. We're going to do f prime of x, and that's negative 1 over x squared. Hopefully you have that memorized. Otherwise, think of f of x as x to the negative 1 and apply the power rule. All right, the derivative of g of x is going to be easy to do. 5 has a derivative of 0. 3x has a derivative of 3. All right, so we need to find f prime of g of x. So I'm going to plug in that 3x plus 5 as my input into my derivative of f. So I'm going to have negative 1 over 3x plus 5 squared. Now I need to take that and multiply by g prime of x, which is just 3. So I have negative 1 over 3x plus 5 squared times 3. And so my final answer for my derivative is negative 3 over 3x plus 5 squared. Okay, guys, thank you so much for watching the video. Do what problems you can in the problem set, and bring your questions and yourself and any problems you've been able to solve to class. If you need me before then, you know where to find me. Thank you. I hope you have a great day.